The discovery of quark matter inside the neutron stars is a game changer. In the last episode, we left you with some burning questions. What does discovery of quark matter means for our understanding of the cosmos? How does this exotic state of matter within neutron stars reshape our view of the universe's building blocks? I spent a week to research all these questions before putting them in front of you. The answers are mind-boggling, so let's uncover these mysteries. To appreciate the significance of quark matter, we have to understand a bit of the cosmic background. Our current understanding of the universe relies on the standard model of particle physics, which describes all known particles and their interactions. This standard model of particle physics states that quarks make up protons, neutrons, and other hadrons. Quarks are never found alone in nature and are always confined within hadrons. This standard model, however, doesn't account for extreme environments like neutron stars. The discovery of quark matter in neutron stars challenges the standard model's predictions because it suggests that the fundamental particles, quarks, behave differently under these extreme conditions as soup of quarks found in neutron stars. This means the rules of particle physics that we've been using may need to be adjusted or expanded to account for these new findings. In simpler terms, it's like finding out that water behaves differently in outer space than it does on Earth. The discovery of quark matter in neutron stars is like a cosmic laboratory that shows us that the basic ingredients of the universe may change under extreme conditions, and this challenges our current understanding of how the universe works at the most basic level. So, what does this all mean for our understanding of the cosmos? The implications are staggering. Firstly, quark matter could help explain some of the most energetic and mysterious phenomena in the universe, like gamma rays bursts and fast radio bursts. It may also have a significant impact on our knowledge of nuclear physics, even right here on Earth. But that's not all. The discovery of quark matter within neutron stars redefines the building blocks of the universe. It suggests that the strong force, which is the glue holding quarks together, behaves differently under these extreme conditions. Let's discuss how does this challenges our understanding of how the universe's most fundamental forces operate. In particle physics, there are four fundamental forces: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. These forces are responsible for all interactions in the universe, from planets orbiting stars to atomic interaction. It means that quark matter reveals that our understanding of how the strongest of these forces, the strong nuclear force, operates in extreme conditions is incomplete. The behavior of the strong nuclear force within a soup of quarks, such as one found within the neutron stars, is quite different from how it behaves under normal conditions within atomic nuclei. Under everyday conditions, in the nuclei of atoms, the strong nuclear force is the glue that holds protons and neutrons, which are themselves made up of quarks together. It's an incredibly powerful force, but it acts only over very short distances. In the extreme conditions found in the core of neutron stars, the pressure and the temperature are so high that protons and neutrons break down into their constituent quarks and gluons. This forms a hot, dense soup of these particles called a quark-gluon plasma. Inside this quark-gluon plasma, the strong nuclear force doesn't behave in the same way as in atomic nuclei. Normally, quarks are confined within protons and neutrons. But in this extreme environment, they are deconfined. This means that quarks are no longer bound within particles but can move freely. This behavior challenges our understanding of the strong nuclear force and the basic fundamental theory which says quarks are never found alone in nature and are always confined within hadrons. The strong force acts differently when quarks are deconfined, and this presents a significant puzzle in particle physics. Understanding how the strong force behaves in quark-gluon plasma is an active area of research, and it has implications not only for the behavior of the matter in neutron stars but also for our understanding of the early universe. The conditions in neutron stars are somewhat analogous to those that existed shortly after the Big Bang. So studying them can only provide insights into the universe's early movements. This discovery challenges and expands our knowledge of the very fabric of space and time itself. In summary, quark matter within neutron stars revolutionizes our perception of the universe. It not only expands our understanding of these celestial giants, but also challenges the very essence of the cosmos. This discovery has the potential to reshape our scientific theories and quite possibly the way we look at the universe itself. So, there you have it, fellow cosmic enthusiasts. The secrets of neutron stars and the exotic quark matter they house are transforming our understanding of the universe. If you found this mind-blowing, make sure to hit that like button and share this video with your friends who are curious about the cosmos. Don't forget to hit subscribe